Hello, everybody. Welcome to this channel. My name is Danny, and this channel is about node.js core. So I'm going to give you a series of node.js core and guide you through some of the features about node.js. In today's lesson, we're going to start off with streams. So let's get started. So in terms of Node.js streams, as I said in previous lesson, we have a lot of streams in and a different definition in different languages. But streams, when it comes to definition, is pretty much the same. And in Node.js, there are some of the particular features about these streams. So there are 4 types of streams in Node.js. We have readable streams, we have writable stream, a duplex stream, and a transform stream. They also are gonna give you a pass-through stream and lazy stream. These two are now the standard, but we're gonna get into that in other lesson or in other video. And when it comes to streams are objects, and this object or streams are inherited from different interfaces or just implemented from different interfaces. For example, streams are implementation of a event emitter. So that means streams can leverage some of the event emitter, and we can use event object.on to define a few events handlers for different events. When, for example, we have a lot of event already defined for these 4 types of streams. So if you head over to the official guide, they are very detailed triggered event for different streams, so you can reference. So another way, streams are async iterator. So that means you can use for a way of this new syntax to simplify your coding. Just the for way of to create your a loop, a synchronous loop for this stream. In every circulation or in every round, a stream just yield a chunk for you to operate or to deal with this particular this specific chunk. So that means that streams are async iterator. So for right side hand, we have a stream. For example, it just gives you a different examples for readable stream and writable stream. For example, here we have HTTP responses. So readable stream or writable stream is kind of like a lower level stream, just HTTP responses can be seen as a high level object, so which is inherited from readable stream. When you look at these 2 lines, you can see the same object. For example, HTTP responses can be readable stream and writable stream. That really depends on how you or your where you stand, or just based on the perspective you of your observation. For example, if you're standing on the client HTTP client, so HTTP response is just like, is an incoming message to you, to your HTTP client, so that is you read the client, you read these responses from this stream to your client. Another way is, on the contrary, the request message is, just if you when you're standing on your client, just request is outgoing message. So you write your request to the writable stream, then to the underlying socket. That means it really depends on your perspective of observation. And another example is FS, file system read stream. So you read your file, you read your underlining. For example, file system or specific file is underlining resources for you as a programmer, and you read underlining, or just you read underlining specific file system, a file to onto the stream, then you just your application then use this stream to your stream use this data from this stream. So on the contrary, to write something, if you, for example, you have an application, you have some data you want to write to your specific, write to the writable stream, then this writable stream just write your data to the underlying resources, which is a specific file eventually. Another thing is for crypto, zlib, a TCP socket, or in terms of TCP socket, it's bidirectional. So for this one, sockets are readable streams and writable stream because it's a bidirectional communication. And surely we have standard out and standard error, standard in as our pretty when we want to improve something from our terminal, we want to, or if we want to console log something to your terminal, you have to use a standard in and standard out frame for this very basic operation. Yes. Okay, let's move on to the next one. Now we're just going to, I'm gonna talk about a first one, which is a writable stream, because the writable stream is a simplest stream out of these four. So let's get started. So writable stream, we usually talk about a specific stream with two parts. Consumption parts, that means when you are a consumer, how to use this writable stream. Or second part is when you are creating your child class or a subclass. When you want to create your own writable stream, so that means you are a implementer. So we just break it down to two parts, one for consumer, one for implementer. So in this lesson, we just you just as a consumer to leverage the writable stream. So the definition, or just give you a very simple what is a writable stream is it is a abstraction for a destination to which data is written. That means you want to, for example, you want to write your data to a underlying resources. So by using this writable stream, simplest uses or simplest syntax you can follow is you just grab something as your indable your writable stream, and then you just for example, in this case is my stream dot write, just write something to your to this stream, or write something again, and then you just given an end to finish up all writing operation. So pretty simple when you want to use it as a consumer. And so for writable stream, every writable stream can fulfill or can trigger these events: close, drain, arrow, finish, pipe, and pipe. We're going to talk about drain today, and close, arrow, finish is pretty common for every streams, for every type of streams. And pipe and unpipe, we're gonna push these two back to pipe session or pipe session. Yeah. So there are a lot of methods, public methods for you to use for writable streams. I just pick one of them, two of them. I think one is a write.write, one is .end. It's a pretty important one, pretty important too. So if we look at the write signature, writable.write, then it just takes in parameter, trunk, encoding, and callback, the three parts. Trunk, you can just give string type, or just buffer, or unit 8 array, or any types of node.js, any types of object. So these three, that leads to a concept for us to understand. So for stream operation, there are two modes. One is non-object mode. The other is object mode. So now for non-object mode, we just manipulate, we just read or write those string or buffer, unit 8 array, kind of like a string flow or buffer flow. And for if you want to have it in the object mode, you can you can give it any type of Node.js object. That means the object mode. You just you want to write an object, JavaScript object into this stream. So you are going to pick this mode, object mode. If you're gonna just write a string or buffer, kind of like traditional flow, you just use non-object mode. Non-object mode for these three, object mode for any, for the last one type. So parameter encoding is a string or not. If you leave it as it is, or just default value is UTF-8. So here's we just want to give you a concept that's encoding it's a string and a buffer. What is the difference between string and buffer? That string kind of like a high-level object, and the buffer is a little bit low level. So a stream object becomes buffer object by using encoding. When you encoding a string by using a particular encoding mechanism, for example, UTF-8, you can you're gonna have so the string becomes buffer, change to buffer by encoding. So inversely, a buffer can be decoded to a string by using specific mechanism, decoding mechanism or encoding codec. So that means encoding mechanism is from high-level string to low-level buffer. Inversely, decoding means you just want low-level object to change to the high-level object. So that's the inverse operation. And also the last parameter is a callback. That means when you finish writing, when node.js finish writing, the callback will be called. Yeah. I just return value is pretty essential for us to to focus on, because we just gave you a emphasis on this, and just which leads to another concept, which is back pressure. So return this write command, or this write method will return a Boolean value. If it's a returns false, that means the string wishes for the calling code to wait for drain. That means the stream's internal buffer was full. Then when you write again to write some data, write some extra data, or just write the data, and then it returns the false. Or if the internal buffer is not full, just return true. Kind of like just those returning value, just kind of like a trigger, or just not like a trigger, like a signal, which is giving you a signal for internal buffer status. And we move on to the, so the returning value is connected to this very important concept, which is the back pressure. I just want to talk about back pressure. So if just take a look at this diagram here, this is a writable stream, and this is your application. And if you call, just write this streams.write data, some data into this stream. You just put some data into the internal buffer. So for internal buffer, shortly the internal buffer had this length for capacity. So 16K for by default, 16 byte by default. And this length or capacity, we call it high watermark. So just remember this term, high watermark. That means the internal buffer's length. Or just, in runtime. In runtime, length, not a fixed, always 16K, but just a runtime length or capacity, current length, I should say. When the buffer data go beyond high watermark, write statement returns false. So more incoming chunks will go to other space to take up other space instead of the internal buffer. Meanwhile, at the same time, the fully loaded, because your internal buffer is full, fully loaded stream will be written to underlying resource. That means on the right-hand side, those kind of loaded data will be drained to the underlying resources. When those data was empty, was drained, or they trigger the drain events. So when you see the drain event fired, that means the internal buffer has been emptied. So that means the results will end up with two options. So here, this process we call back pressure. So it is by manipulating high watermark and this false or true Boolean value, we can see the internal buffer status. So if you ignore this status or ignore this back pressure, just quickly write continuously, as quickly as you can, just write from your application, just quickly write all of the data to this writable stream. That would take up more node memory. That means you use a lot of node memory, extra memory, to hold this data. So the second option is recognize this and respect this back pressure. You just you got true, you got false. You just respect this returning value and waiting for the drain event, or just write something in the drain event handler. So that means when the internal buffer is full, you just slow down your application's writing process and control your speed, your steps. That's a correct way to write your data and leverage the writable stream. Okay, let's move on to our snippet time. And we're gonna use two options. We're gonna show you or demonstrate two options for you to reference, and also give you some examples for this to demonstrate this two options. Okay. So here we have a writable consumer.js. This file is just already finished writing this, and let me see. I just want to give you a comparison for by using different options. One is you just ignore this back pressure signal. For example, you just grab a chance, which is a third-party library, and help us create a random string with particular size, and it just create a stream writable stream from fs.create writable stream, and by using this test.tst. This is because the purpose of this snippet is to write random string continuously to this test.tst. So it's pretty easy to understand just what I told you. So here's a loop. So it loops 20 times, and for this string and this buffer to write into the writable stream, and writable stream will send out this those data into the underlying resources, which is the test.tst. And I also give you a console log for the specific properties, which is an index for circulation, index of circulation, and stream back pressure is every time I execute this write statement, and it gives you a return value. This is a return value, just a signal for back pressure. And also I console out a stream writable buffer. This is an internal property. Just I just want to give you some tip and hint for you to observe this, grab this writable buffer, what it's like while running, and also writable length, stream.writable length. Writable length is another public property for writable stream. So let's run it. Pretty easy. Just I'll give you the whole code online, so you can download it and modify it. You'll just try to test it. I also pulled up active monitor to try to grab a memory uses. Hope we can grab, because the the frequency of this active monitor memory monitoring is 1 second, but it's not as quick as the execution of the snippet. Might be my so right. All right, just 36. So I just give you some of the explanation for the output. 0 for index or circulation, our loop, which is we have a loop of 20 times. And false means because is a back pressure signal that return value from the right statement. And now the data, the buffer or the data we wrote is 1.6 million byte. Sorry, megabyte, 1.6 megabyte. So it's larger than the 16K high mark pressure, high watermark. So it return false. So it return false every time when I loop our circulation. I just write 1.6 mega. So it give every time it gave it false as a return value. False, 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 false. So this is a trunk. So every time that means the internal trunk, you can see, just zoom out a bit. And this is a writable length, it's 1.6, 3.2, and 4.8 is accumulated gradually. And at the end, we have 32 megabyte. We have 32 megabyte as a writable length. So you can see that whole procedure. That means that our application just write a whole bunch of data as quickly as they can, and just ignore just ignore the stream back pressure signal. But test.txt, let me just test.txt. When we check underlying resources with this test.txt, which is size of 32 megabytes. So it guaranteed that your data will be written to this file, which is underlying resource, and even no matter how quick, how fast your application just write to this stream. So that's option 1. So, but don't do that because the memory, it takes a lot of node.js memory. If you ignore the signal, just I comment out this first one. And change this byte to 1.6 kilobytes, and we enable this. Let me check. Let me check. Okay. So here is option 2. We recognize this back pressure. We respect this back pressure. So as the back pressure comes in, we slow down our write statement, or slow down the speed of our writing. So the file size is 32 megabytes, and we just give it a total length as a cumulative file length, and create a writable stream, and open up another file, test1, as our underlying resource. And also, I just initiate a stream back pressure, this valuable. And same as the previous one, I just use a chance to random create a string, which is 1.6 kilobyte length or size. And then here in this statement, it's just translate augmented string to the buffer, because this is the encoding procedure. If string will become buffer by using encoding method, and in a reverse way, buffer will be decoded. Buffer data will be decoded and to become a string. So decode and encode is, the opposite action. And here's a do circulation loop. So do write, we write something and let them trigger this return value, and just accumulate the length, and put it into total length variable. And we just while the stream back pressure, because we care about this back pressure this time. If it's forced because they go beyond the high water mark, so if it is a change to false, we just stop this loop, just stop writing something into the stream, and kind of like slow down this whole process. And we also have a stream on as I give it a event drain event. I give it a handler for drain event, because when the stream back pressure equals false, the writable stream will execute the drain action. When finish this drain action, this event will be triggered, and then this handler will be executed. So it just compare with our final file size. If it's not enough, and we just still write. We write again to the file, and just also probe this stream back pressure again, and also console log those same variables. for you to observe the internal operation. And this is also another same loop. If it exceeds the file size, then we just finish the writing. And we also have a finish handler for all data sent moment. Okay, that's it. That's I just run it. So you can see the whole output. We open up this, try to console log this one before this event is fired. So let's get started. Run. You can see the memory. Just Control C. Because so many outputs out there, just writable consumer, writable consumer, node.js. I try to put out all of the output to a file so we can analyze it easily. Okay, result.log. So open up this to see what's going on there. Okay, I just put this output because this output is too big to see. So I put this output to redirect to yes result.log. So we just already open up two panels, one for our code and the other for the output in result.log. So it's just pretty easy to see for all of us. And we at the beginning we just started this loop, do loop, and for every loop we just write 1.6 kilobytes. So after 10 times, which is 16, go beyond 16K default internal buffer size, which is stream back pressure will change to false. So that means that the loop will stop. So you can see that. So and after the stop, we console log this first line. So the total length is 16K, and false means there's a back pressure comes in, and writable length is 16,622. So at this moment we stop the write, and then we're waiting for system to drain, for writable stream to drain all of the writable data. When the drain process was finished, then we start the new circulation, or start a new loop, write again. So start writing again, Then we write 1600 bytes, and back pressure will be true. That means we still have room to write into the internal buffer. Then you can see that after several loops, true, and the writable length has been accumulated to almost 16K, which is high watermark. And all of a sudden there's a force. Force means there's a change for back pressure. Back pressure just fired up. And this time we're waiting for the drain process again, and we started the do while loop again. So you can see we loop, and write data to the internal buffer, and waiting for the high watermark for back pressure happens. And then when back pressure happens, then the drain event, process and drain event will be fired, and then again and again circle around itself. And finally, they just write up to 32 megabytes, and all data sent, or there's no new data coming in. So that's it. That's for today's lesson. Hope it helps, and hope you enjoy it. If you have any comments, just let me know. I'll just write down in the comment below. Have a nice day.